Hello and welcome to the third part of the Sakura tree tutorial. In this part, we'll continue part 1 and work on the trunk of the tree and the main branches. If you watched the first part, you remember that we ended up making a prototype in Unreal consisting of several splines, and then we merged all of them and exported at the very end of the first tutorial. And we stopped at this point where we're in Houdini, ready to continue with this. So let's see what's going on here. So first we bring in file node, which is this. And in this file node, we select the file that we exported. Once again, it's the very end of the tutorial number 1 in this series. So we import this file, and if I select this, you will see that this is huge in size. This is because there is discrepancy between units in Unreal Engine and Houdini. Unreal Engine does everything in centimeters, and Houdini is making everything in meters. So when something is 500 units in Unreal Engine, which is 5 meters, 500 centimeters, Houdini reads it as 500 meters. So what we need to do next is, well, first use clean node to remove all the groups and all the attributes like you see that there are plenty of stuff from FBX files, inherited from FBX files. And here we have nothing except point positions. So we clean, just turn on this two checkboxes. And after that, we do transform. So we scale everything down, uniform scale from 1 to 0.01. So we divide it basically by 100. And now we have our correct size, correct tree. So what to do next? As you can see, if you remember, our plane was, so we repeated plane along the tree trunk, along the splines. And here now we have triangles because of the FBX, but it doesn't really matter. What matters though is we need to first fuse everything together because let's see. So if we select, let's bypass this. So if we try to select only the edges that do not have neighbors, you'll see that there are places where for some reason the mesh looks like it's split. And so to avoid this, first we use fuse. So we're fusing the points, the disconnected points together. Let's see if we can like you can see that there are points that they have duplicates. So like the mesh is split here. I don't know the reason, but after we fuse it, all the points now unique, connected together. So these are my settings. So basically 1 millimeter is a threshold distance for snapping points together. No, I didn't change any settings in this node. Then we use connectivity node. What it does is it adds attribute class to all the points. You can see them in here in our geometry spreadsheet. It adds a class to the set of connected points. And while now we've fused everything, now the whole trunk becomes one mesh, one piece of connected geometry. And so Houdini with this node connectivity, and I didn't change anything here. We have 10 classes because we have one trunk and 9 branches. We will need this. Actually, we need this only because of Houdini 20. And by the way, this tutorial will work good with Houdini 19 and 20. I usually use 19. It's rather a question habit, and also I use Unreal 5.1 for some of the projects, and HDA work like standard way from 19 to 5.1. That's why. But it also in Houdini 20, you can see that it also works the same. And there is only one difference, and I'll show you where there is. But connectivity node I added only because of Houdini 20. So first we do this. We assign integer attribute to every point of every piece of connected geometry. So every point of trunk gets attribute 0. Then what we do, we add a group node. We make group name edges and group type edges. and we uncheck base group here, and we only check include by edges and unshared edges. So what we do here, we select all the edges that are on the side of our planes, and in the next move we blast them. And so this is the question, this is the difference with Houdini 19 and 20. If you can see, so the only problem here is that we also blast the very beginning and the very end of the branch, and it will cause a tiny little issue later, and I will show how to fix it. So we make every branch a little bit shorter than it was in Unreal Engine, but bear with me. So in Houdini 19, when we blast edges, group edges, the group that we selected here, it leaves us with just a spline. As you can see, all the points are repeating, but still it's still spline. And we see that each edge becomes its own primitive, so it's a mess. But if you go to Houdini 20 at this point, so we do the same, we select in group, we blast in it. Now Houdini 20 doesn't do what it did in 19. We only see the bunch of dots. And after that, we need to add them together. I'll show you this example. So we use add node to connect all the dots together, and we don't do anything on the first tab of the add node, but in the second tab we select connect points by group, and we here use attribute, and we know that each separate piece has its own attribute, and it's an attribute class. So that's what we do here. If we would just do all points, then all of them will be, this is default state, all of them will be connected. It doesn't matter that they belong to different pieces of geometry. And that's why we do this. We do by attribute class, and this is how we have our spline. In Houdini 19, this problem is already solved for us here, basically, even though all the splines are repeated many times. But we still can do this node, and in this case it doesn't matter. So after we've done this, now we need to fix all this repeated geometry, and we for that use node polypath, which just converts all this mass into one spline. So you can see that the trunk becomes spline number 0. And this is important, and again, this is something that I paid attention to in the first tutorial. When we are ready to convert our set of our splines into the tree, we need to make sure that the trunk, BP trunk, goes first. So when we select in all of them before export, this one needs to be selected first. All the others do not matter, but this has to go first. And then we select all of them, all the rest, and then we merge them and export them. This is how we ensure that in the resulting splines, our trunk will be spline number 0. Even though, well, in this case, again, it's not that critical, but it's a good thing to just better to do that. Another thing that I mentioned in a first tutorial is that our tree here, our first spline, is not necessarily, as you can see, its pivot point is not in the beginning of the spline. But when we're making trees in Unreal Engine, in Houdini, I'm sorry, we better have our tree to begin at 0. So the trunk needs to be situated. The first point of the trunk needs to be situated at 0 coordinates, and it's kind of far away from it. And there is a pretty easy way to fix it. So let's turn on the numbers of the points. So that's how we do that. Well, first we do sort by Y. So we need to find, we know that our trunk is the first, our trunk is the lowest. So we need to find, in all the points of our tree, you need to find the first one, the lowest one. So that's why we do sort by Y. And you can see that the very first point is number 0. Now we use blast node with points group type and delete non-selected, and we blast in everything but our first point. And from here we create attribute promote node, and we used position because of our point, and we promote it from point to detail because we need to remember where this point is situated. And you can see that if you go into details tab in our geometry spreadsheet, you will see that it knows now that its coordinates in x, y, and z axis. And we will use it. So we put these nodes into like separate branch because this is only, and also I renamed it, attribute promote, I renamed it to start position just to be able to find it easier later. So then we use transform node, and let me show again, let me create it again just for the sake of better understanding. So let's say that we have our tree, which is not starting in the beginning. Now we know, so in X, it's positioned a little bit into negative part of X. So what we need to do with this, if we need to move it in a positive part of X, exactly the same distance as it is right now in negative. So we know that it's this point, the first point of the tree, the very beginning of the tree is minus 0.04 in X. So now what we need to do is to move the whole tree on the same distance, so 0.4 in a positive direction, and then it will be on 0. And then we need to do with our x and our z axis, so only in not in vertical. In the vertical axis, we leave it as it is, so it's not on the ground, which is what we need right now, but we need to move it to beginning of the coordinates in horizontal space. So that's how we do it. We go into our transform node, and as you can see here, I'm using minus in the very beginning. So I'm negating whatever I have in my details here. I'm negating it. So if it would be in a positive x, then we'll do minus. So here I do, well, first let's do just detail. So we're looking for our detail node. Start typing detail. Okay, then quotation marks, 2 dots and slash, and we will see all of our nodes. And while I know that I named it start position, I can start typing it and I can see my node now. So we looking for information from the node which is called start position. Now, comma, and now what's the name of the detail attribute that we're looking for, and it's P. So the detail attribute is P, capital P. And now we also have, here we also have 3 of them, and they are 0, 1, and 2. So here I need P, which is 0. And you, hold on, something didn't go, oops, yeah, because here it needs to be comma. Okay, so now I have, you can see that now I'm looking at my detail attribute in here. And as I said, now I need to negate it, so put minus in front of detail, and now it moved in X direction. And here I do the same, exactly the same. So this is my X position, and this is my Z position. So and for Z we use attribute number 2, which is third, because everything starts from 0, 0, 1, and 2. So 2 is Z. So and if we look into my original position, so now we have our tree. You can see this is its original position, and now it's right in the middle, right over the center of the world, but not in vertical, and we need it. So also what we need to do now is to separate a trunk from branches. There are many ways to do that. Probably easiest would be to do something like, well, we already made sure that our trunk is number 0. As I mentioned before, we can do like this. So we put a primitive number 0 and we select it. So it goes into here. I mean, it goes from here, and from here, if we plug in null node or any other node, we'll see the rest of them. So this is one of the ways to separate them. The other way is where I went for right here, is to go for group, name it trunk, primitives, uncheck enable, and check keeping bounding regions. And this is our bounding region that all of these are default settings. Only thing that I did is not default is include partial connected entities. So it partially touches. We know that our tree now starts from 0, so we assume that it will be somewhere around a meter from the 0 in vertical, and with this we just, if it touches it, it all selected. And after that I did split again, but this time I split it not by the number of the primitive, but just by the group name. So, and after this we started to work only with our trunk. So let's go take a look. So our trunk is separated. Now we have a sort node, and in sort, let me look at the numbers. So before that we have our beginning of the tree was at 0 here, and this was the last point. Now we need to reverse them. So we still want to sort them by vertex order. So by the same order that they were before, we just need to reverse them. So now our 0 is here. So let's have our actual 0 of the coordinates. How do we do this? And also, important thing here, like if we create a tree, let's see, lapse tree generator, which we'll be using later. If we use a tree right from here, this doesn't look good at all. The problem is that it's not touching 0 coordinates. What about from here? Ooh. No, first. Oh, okay, sorry about that. So yes, first we need to, that's the tricky part about trees in Houdini. They behave really weirdly if the tree doesn't start exactly at 0. And also, if the trunk would be, like, you would say, okay, why didn't we put it down right here? So let's see what will happen if we would. It will be 1. And so this is our trunk. Now it starts from 0. And this is our tree. So it behaves weird, and it's hard to, I don't know why. Like, seriously, it's really wonky from time to time. And one of the reasons might be is that it's not straight. You always want, especially later with roots, you see what I'm talking about. You always want it to start kind of like going vertically, at least in the very first point. Just go like straight up, and that's why I didn't do that. That's why now I'm going to delete the channel and put it back to 0. That's why I wanted to better use some more nodes and actually make a straight vertical line from wherever my tree starts to 0 coordinates. And that's exactly what I'm doing here. Oh, by the way, maybe this will work. No. Yeah, this sometimes it's wonky, but it's also a really good way to create trees, as in my opinion. You just need to kind of adjust to its rules. Let's put it this way. Okay, so after we did this sort and changed the order of the points, and now they start at 0, we blast in the very first point, because again, now we know that it's point 0. And we also add a new point with this add node. Just use add node. You can see it's empty. There is nothing going on. Just add plus here, number of points, and you have 1 point at exactly 0, 0, 0. That's what I did with this node. So I added 1 point exactly at 0 coordinates. And now I merged my newly added point and the blasted point from the trunk, and I merged them together. Now I have 2 points, 0 and 1. And also now I'm using add node again, and this time I go to polygon tab and I just select by group, and it just adds 2 points together. We only have 2 points. Now we have them added together. And now we need to add them with our trunk, with our original trunk. So this is what we have so far, and we also see that now we have two primitives instead of 1. So again, and 2 points in this point, in this location. We do fuse, to merge points together. And also now I want to move this point number 0. Let's see. Okay, point number 0. Look at it. And I'm moving it downwards. I'll show you later why it makes difference. I'm just moving it in 40 centimeters, 0.4 meters down. And in group, I select 0, and I make sure to select group type points, not primitive, because by default it will be this, and it will move the whole primitive down, primitive number 0. That's why I make sure that it only affects point. And after that, we do polypath again. That will allow us to, that will convert 2 primitives that we had here. We'll convert it in just 1, primitive number 0 again. We smooth it a little bit. Like you can see, there was a harsh edge here, and now it's smoothed. And also, I want to do resample, and I have it for 2 purposes. Well, first, we add curve view attribute. We'll need it just a little bit later. So what it does, it's, if you look at your points, it adds this new attribute starting from 0 and going all the way up to 1. So basically, it takes the whole curve, no matter how long it is, as the distance between 0 and 1, and it interpolates to every point of this curve how far it is from 0 or from 1. So it interpolates the distance, split into, like in our case, it's they are on the same distance from each other. And so you can see that it slowly grows over here from 0 to 1. And so we can, like 0.5 is exactly the middle of the curve. It's very, very convenient way to find out the distance along the curve. Also, what I'll edit later is this length 0.2, because like if you remember in Unreal, our blueprint section length was 20 centimeters. And if technically we don't need to make this 0.2 because 20 centimeters is 0.2. So in this case, it's the same. So basically what we do, we don't do nothing here. Like I could just uncheck it, and it was unchecked in the beginning. And like, okay, we don't need to resample. You can see that the shape is the same. We do not need to resample to change the distance between points. We just only need to resample to get a curve view attribute, and also smooth it a little bit with subdivision curves. But if we do this, we do not change really points, not changing much, at least it's kind of almost not visible change. But if we make changes later here, and we would want to make changes here, this is how we'll make sure that there will be the same amount of points. But once again, this can be unchecked, and if you'll have more points, it doesn't matter in this case. But I decided to add it so to maintain the same frequency of points as we had initially in Unreal Engine. And after this, I use my curve view and attribute remap node to assign p-scale attribute to every point. As you can see, now we have a new p-scale attribute. And why we do this? When we will be working with a tree, p-scale, actually, it's not even really usable in this case. Let me see. I know that it's, we will definitely need it later. Okay, yes, I did change a little bit my settings when I was preparing for this video. So for the trunk, it's not really that important. But I did have different settings before. I just decided to make it somewhat simpler, so it will be simpler to explain. But then again, we would need it in branches. So in this case, right now we can forget about this and this attributes. So let's say, okay, we have our spline, and now let's create tree trunk generator node and plug our trunk right in here. And this is default. This will be your default tree if you just plug it into trunk with no change in settings. because you can see that the trunk goes a little bit thinner in the end of it, and also has UVs and stuff. Also, but we will override many of the settings. So what did I do here? Well, first I added tree controller node. It's this one, tree controller, and I did change some of settings. First, I unchecked gravitropism here, so the tree would not imagine that it has any gravity enabled. We're doing this because we want the tree to completely follow the splines that we created in Unreal in our prototyping process. So we don't want to do any more we don't want Houdini to do any more transformations for us. That's why I unchecked trapezium. Also here I unchecked line noise to not allow it to change my spline, and I also did some changes in mesh noise. And that's it for my controller. And it will be plugged into branches control. So it's kind of good idea to use a controller for the same settings to keep consistency with the tree, with trunk and branches as well. So also what I did here to get this shape. Well, first in general I selected radius. That looked good to me. And as you can see, it's changing if I change it. And I just did some changes to the spline shape because I wanted the bottom roots area to be much wider. So here it has multipliable value by 1. And at almost 1/3, it's already starting to get a little bit thinner. And then by the end of it, it's only 10% of its initial widths. Also, so there is nothing here, nothing changed here. And also in trunk shape, I enabled roots, and I changed the shape offset. By default, it's 1. And I have this. I did change a little bit the settings, but what's more important here is that I used the position ramp for the roots because like you can change here. You can change the position of how your roots will work to compare with the rest of the tree. So as you can see, the first point is and I changed all of them to be splines. The first point is just 0 position of value 1, and then it gradually becomes thinner. I mean the roots area, and then thinner, and then super thin, and it's monotone cubic. And I also do one twist, so I'm twisting the trunk around itself, and you can see that if I do 2 twists, it will be more twisty, and by default it's 0. So it's kind of I found it less interesting, so I like this version better. And that's pretty much it for the trunk. So here we have our trunk, and this is the thing that kind of helps, kind of fixable with all our manipulations with adding a node in the bottom. So let's see if I plug it from here. Again, why it goes horizontal, I have no idea, and where it changes, even wondering. Polypath? No. Oh yeah, so in here where it changes only here where I move my, oh no. There are 2, okay. It needs to be only one primitive. And so after we did polypath, before we had 2 primitives and it was like all broken. But after we did 1 primitive, it becomes like normal, finally becomes normal tree. Okay, so as you can see, if we don't do smoothing, its shape is not pretty. But after we do smoothing, it goes, because it's not straight going up anymore, very restrictly up. Now it changes. Now it does it like have this nasty angle, so it doesn't touch the ground at some point. But this is the case. This is the case why I did this transformation here. So I moved the first point in minus 0.4. So the Houdini trees are always starting from 0, and while our tree actually starts lower than 0, minus 0.4, Houdini kind of moves the main tree up. So you can see this is our original shape. Let's find a position where it's already moved in its position. Okay, so this is our original shape, and this is the shade of the tree that we made. You can see that it went up on its own only because I moved this point up. If I put it back, if I undo this, only one point in the bottom causes the tree to go up the same distance, and we can use it to our advantage because now the tree went up, and you can see that the roots area moved a little bit too and became straighter. And now, after it did it, we can actually move the tree down on its location where it's supposed to be. And now the roots are going below the ground. And in this transform, I'm using, as you can see, a reference from this transform. So I just right-click, copy parameter. And here I just did, again, when it was empty, right-click, paste relative reference. And there I have it. So if I move this point even lower, the tree shape will change. The roots will go deeper now. So this is kind of trick that allows to negate this effect of the bent root. Like if I do just minus 0.2, it will be like almost on the ground. So again, in your case, you might not even, depending on the shape, you might not even need it. But then just don't do this, or just do 0, and it will be just original shape. But in my case, while the trunk is crooked, the bottom part is crooked too. So this is the easiest way to, and I found that the value minus 0.4 in my case works the best. And also after that, I can clip it at 0, or clip it, so it will go in the ground just a little bit, so minus 0.1, so I'm allowed it to go under the ground 10 centimeters, and this is my tree trunk. And from here, from this node, let me delete this. From this node, I have two outputs. I have out trunk, we'll need it later, and I have out trunk spline, and I do exactly the same for the trunk spline. I do the same translation as here. It's just a copy of this node. So, and this is my final spline. We will need it later. We'll be creating secondary and tertiary branches. So let's go back and work with our branches. If you remember, here we selected our trunk, split it, and now we will address the second portion of the split, which is, once again, let's attach null node and look at it. So these are our branches, and for them we'll start a for loop to address each branch separately. How we do that? Just standard for each named primitive. Actually, no, it's just standard for each. Piece attribute name. Just for each primitive? Oh, for each primitive, right? Because we have each spline is its own separate primitive, so we don't need any attributes. And here we have 10 of them, and you can see with single pass, we can loop through all of them and apply all our settings that we need. So this is the standard for each loop. Let's take a closer look at it. We'll go here and let's select here, I said, and let's select single pass, and we'll look at one of the branches in details. Okay, so first we have a spline, one of those. We do polypath for it. Let's see what it was here. I guess it was necessary here, but I'll prefer to be rather safe, I guess. Yeah, nothing changed. Polypath here, it's not necessary here. After that, I do sorting of my points, and I do again by vertex order, and I reverse them because I need the first point to be close to the trunk. And also for the moment, let's undo this, all these nodes. Let's imagine that we're creating it from scratch. And also, I cannot use, in this case, I'm sorry, my cat came to be annoying. I decided to treat every branch spline as a trunk, as a separate trunk, because the branches node didn't really work in my case. So we will just use the same trunk tree generator. I did adjust it a little bit. I'll get back to it in a moment. So, oh well, this is a default state of affairs. That's why we need this and this. Okay, this is my length. Fluffy, no. Excuse me. Cat is not making it any easier. Okay, I'm sorry. So, if you look at the result, just don't pay attention to all of this. It's just needed for the trunk. Where is our tree? This is our tree. So this is our branch that is obviously, beginning of the branch has to be here and end has to be here, but it's reversed. You can see that this is like the opening that actually needs to be right at the trunk. And even if we do not reverse it, like you would say, okay, but we just reverse the points. Well, yes, we did, but the vertex points below it, they're not getting reversed, and so these two nodes are actually to do just that. So even though we reverse the points, tree kind of did notice that. For it, it's still 0. So now we need to kind of store our new reversed point number. So we're creating a new attribute. It's a node attribute create, and we call it old point number. And it's integer, it's class point, it's type integer, and for value, we just type at ptnum. So each point number that comes into here gets attribute old pt number. So you can see in here in my spreadsheet. I'm sorry, I'll just get cat from behind my monitor. He's very, very annoying. Go away. I'm sorry. So we assign, you can see it here, point number 0 gets attribute old ptn number 0. We assign to old ptn the current vertex number, current point number. I'm sorry. No. Go away. Not now. Okay, when it's done, now we use attribute copy node. You can see the name attribute copy. I named it reverse order of the points, and now we take our old ptn, the attribute that we just created, and we give it a new name, ptnum. So we kind of reassigning the inverse name. Fluffy, no. We reassigning the reverse point numbers to actual point number to kind of trick the tree to do that. I remember when I first encountered this problem, it took some time to just find out what's going on. So this is the solution. It looks stupid because nothing changes visually, but it changes kind of under the hood. So that's why we do that. And then here we denote attribute delete, and we delete p-scale in case if it was any. It wasn't any, but again, I added it some time ago because I guess somehow I had it before. So okay, we delete a clean p-scale attribute, and we clean old ptn because we don't need these attributes anymore. So now it's cleaner. Actually, we can also clean class, which wasn't there when I was creating the tree. as well. Okay, so now we have our branch reversed, and if we look onto the tree, you will see that it is indeed now have closed ending, and where it's close to the trunk, it's open. And again, if we undo this creation of new attribute, for some reason it looks weird, even though here from the perspective of point number, it's exactly the same, nothing changes. But yeah, anyway, so we deleted our attribute. Now we have our branch ready for measuring, and now we do measure. It's a standard node measure. We use measure type perimeter lengths, and we create attribute name lengths to assign to it. And you can see that it's getting assigned to the primitive itself. So this branch, its length is 3.5 meters. Once again, why do I do that? Why to bother and then bother with 4 more nodes to deal with this? Let me show you why. Let's get tree trunk generator here, and let's just pretend that this is our generator, and let's have all the branches because it will be just easier to see. And it's super fat. We'll just change it in a second. So let's say radius is going to be smaller. And we want the branches to be thinner in the end and thicker in the beginning. Let's do number 2 for better visuals. So here you can see what the problem is. The problem with the default tree trunk generator is that whatever you put into radius and whatever you put into radius ramp, it just assigned it to all the branches, all the trunks in this case. And of course we're using trunk node, so it doesn't care that there can be several trunks. It just assigns it like linearly. So in the beginning of each piece we have the same width, and in the end we have the same width too. And so in our case it will look like this, which is absolutely not what we want. And actually, once again, I could use just a sweep node to do just cylinders and then add some noises to it. But even if we would be working with just sweep node, the problem will be exactly the same, because it will be, no matter what its ramp is, it will assign thick value to the beginning and thin value to the end, and it doesn't matter where it's situated to compare with other nodes, with other branches. That's why we go into all this trouble to creating this length attribute and everything that follows. And it's very useful. I used this setup already in several occasions. So it's really good to know how to do this, how to make it proportional to the lengths of the branch. That's what we're doing here. So we're measuring the branch first. Let's do again our single pass and use our standard the normal path of the events. So this is our branch. We measured it and it's 3.5 meters. Good. Now we do resample. And we do this resample, we uncheck all the divisions, so you can see nothing happens. All the segments stay the same. We only measure curve view attribute. That's the only thing that we do here. And now we want to do remap, attribute remap. So we want to assign a curve view. Well, first we want to change our curve view from just reverse it. Like if you can see here, our point 0, which is furthest from the trunk, furthest, right? Hold on a second. I don't want to misinform. Yes. So right now our point 0 is the furthest from the trunk. Lost it. Okay, here. And it has minimal curve view. So it's kind of the Houdini treats it as the beginning of the branch of the trunk, when we want it to be the end of the trunk. So what do? First we do remap. We just change original curve view to curve view, and we switch from input min 0 max 1 to just reverse 1 to 0 linearly extrapolate. And so here you can see we start from curve view 0, and here we start from curve view 1. So we're just reversing our curve view attribute along the spline. What we do next, we want to keep, so we had our lengths in here as an attribute of our spline, of our primitive, and we want to promote it to detail. So we take lengths, which is primitive, and we promote it to detail, and promotion method is maximum. So we find in our maximum lengths, and again, maybe in this case it's not as useful because we're dealing with one branch at a time, but if we'll be dealing, trying to think when will be useful to store max lengths. You will be dealing with like several branches in bulk then, but anyways, we turn it into detail attribute, and also detail attribute is just kind of easier to, I don't know, for me it's kind of just easier to address later. So okay, we store it, and now the most important part, we go to create a new attribute remap, and now we change it from curve view to p-scale, and p-scale would be the thickness of our branch, and we want this thickness to be the same for each branch, to be the same in the very end of the branch, it's 0.0 right now, and to be the thickest in the beginning of the branch, but not just the thickest from like a ramp, not the same thickness. It needs to be proportional to its length. And so here you see that we use for the output, so output mean is 0.1. It's just what I kind of created, just input it in, and output mean in our result is 0, and output max is our detail from max lengths. So we take, again, you know how to do that, but instead I showed before in transform, you could also do this. You can do quotation marks and 2 dots slash store max lengths. It will be the same result, and you can see the same. But also we can use just 0, meaning that this is the attribute that comes from our first, in this case, the first and only input, so input 0. An attribute name is max length, and it's the first attribute, so it has 0 index. And also I do use ramp here, and ramp looks like it's nothing's going on here, but actually there is something. So in the beginning of the ramp we assign value 0.02. In the end of the ramp it will be 0.005. So we make our branches really, really thin. I guess it was I could just make smaller radius, because you can see radius is really big, but those are the values that I found out before, and I just like you can play with them. You can make those values much higher and then radius much smaller, but somehow I ended up with these values, and so that's what I will show you. And so after we did this attribute remap, let's see what we would have by default. So this is our default node, because this node is a little bit changed. This is our default node. It would be thick enough, but its thickness would depend on the radius. And once again, as I showed before, if we do it for the whole tree, then the branches would have the same thickness in the beginning and the end. In the end, let's do 0.5 for. Yeah, so you see, still it's totally inappropriate result. What we can, and it's not, by the way, it's not using even our p-scale, and you can see it. Actually, no, you cannot see it here. But trust me, it's not using our p-scale, and I'll show you why I know this in a minute. But I modified this standard attribute a little bit to have the situation like this, where branches are actually respecting my p-scale attribute that I'm feeding into them. How to do that? So if you click on the node and right-click and do allow editing of content, you can now enter the node and see what actually it does. And there is just one node here right in the middle, which is called LOD. And you can see here that it's it's assigned to p scale, which we created manually before, but it's not using it. It's assigning to it its own attribute radius, which it creates somewhere here in the top. Band. Yeah, it creates here in the top based on the profile that is right in the tree generator node. So no matter how we feed our p scale here, I mean, no matter how whatever we use for, and you can see that we do create our p scale attribute here. So no matter what we feed in here for the p scale, it ignores it because it uses its own. Let me show the node that I opened. It uses its own radius attribute from the tree generator node. But if we go here and we disable the nodes like this, now we bypassing this, and we're not using loads anyway. So none of this is kind of useful in our case. So we just bypass this node, and it will use our p scale attribute that we just fed into it. So that's exactly what I did, and I renamed it to remind myself that I disabled LOD node. And if I right click and do match current definition, which means I just drop it into default state, you can see that this is what my generator would make it by default. So let me do it again. Allow editing of content, go in and disable the LOD node. So now it will take our p scale attribute from here, and for each branch, as you can see, for instance, for this branch, it measured its maximum value, and it stretched our radius from 0 to 3.5. And if we take some other branch, which is like, I don't know, longer, shorter, longer, this one, you can see that now this one is much longer, but it stretches the same values in between longer lengths, and so that's why we have decent result in the end. That's why we have the nodes, the branches that match each other, that make sense. And that's pretty much it, almost it anyways. So from here, when we're done with making our branches, what we also need to do, we also need to save not just branch, we need to save the splines as well. And you can see that for each here, it has just like here we could just easily take the second output and save it as spline, but here for each one we have one output, so we need to kind of join our mesh and our spline together. So we just create a group node and we feed our spline into this group node, and it's just name it splines, and it's enabled, so the whole spline just getting selected and getting assigned the group. And then I just merge mesh and the result of the group, and now I have my branch and my spline inside of it. And in the result of this whole thing, I have my splines and my branches. And what I can do now is I can just split them. So I'd split node and I select splines, and I'm inverting selection. So in my first output, I will have everything that is not splines. And here are my primary branches. And you can see the gap here, and I will address it just in a minute. So this is our branches, and here we'll put our splines from our second output. And I do resample. Actually, I don't know why I'm doing resample here, because I don't do, as far as I can say, I'm not changing anything, which is fine. And also here I'm using I'm merging our main trunk. How to do that? Very easy. So here we have our null output node for the trunk, and here I can do merge, object merge, and I can either select my object out trunk spline from the list, and while it's capital it goes up, so it's easier to find, out trunk spline, and I select it and it's selected. Or what I can do also is this, I can just grab my null node, no, I can while my object merge node is selected, I can just not click without clicking. I just can grab my null and bring it in here and release it, and that's how it just easier. And so this is my trunk spline. I rename it, and this is my object. And you can see that here I called it in trunk spline, which incoming node. So this is our trunk spline, and we could of course do this, but it's just not clean. And if you have bigger node network, it becomes very, very dirty and very not understandable very quick. So better do object references. So this is our trunk. We also what I'm trying to do now is to prepare my primary branches and trunk for attaching secondary branches. And of course our secondary branches would not be attached right here, like right at the bottom of the trunk. So what I want to do, if I want to cut out the part of the trunk where I'm not going to attach any secondary branches. So first, let's see point number. So it starts from 0 here. Well, first what I do is I reverse it, and it doesn't work. That's weird. Or at least it's not showing up. Okay. Let's see if it will work here. So there is a carve node which allows to carve. It's like, so if I'm carving second channel 0.35, it means that, let me show you in the detail how it works. So this is the full thing, and this is the thing where I carved. I'm only having 0.35, so 35% of the end of the spline, and here would be the same just from the beginning of the spline. The whole spline and change spline. So that's why I do this. And oh, okay. So see, that's the same thing that we had with branches. If you can see, the point order is exactly the same. Nothing changed. Nothing changed. But for some reason, for carve, now it becomes now it's changing. Now it's changing afterwards, which is, I guess, how it's supposed to work. So, anyways, I am carving. So once again, I'm carving the end part of the trunk and only keeping 35% of the top of it, of the thin end of it. And so now we have our branches from the split node, with or without resample, because nothing changed. And we're merging them together. So now we have the end of our trunk and our branches together. So this will be attachment points for the tertiary branches and secondary. We delete an attribute, all extra attributes that you can see. There are plenty of them here. Actually, I probably could use clean node instead of just deleting attributes. Then I'm deleting groups. Again, I did this, I guess, before I was using actively clean node. And we can delete pretty much everything and have a clean setup. And in here, actually we do not even need that, because we do not have a radius anymore. We got rid of it. Hold on, do we even have it? Oh, we don't even have attribute radius, so this is not needed anyways. So this is our this is our splines, which go into primary branches splines output, and this is our branches themselves. Without, you could see that trunk disappeared. And so now we have our branches and we have our trunk, and for just demonstration purposes I can merge them together, and this is our tree. Now let's see what we can do about these gaps. So these gaps showed up because in here, as I pointed out before, after we did fuse for our ribbons and we select our edges, you can see that all the branches are starting pretty much intercrossing each other. But after we do blast, we delete the very beginning of each branch and very end as well, and now we have these gaps. So how to get rid of this? The best way I found is to actually go back to Unreal and make sure that our this portions, the length of each segment is just shorter. Now it's 20 centimeters. If we make it like 10 centimeters, we'll make this gap twice smaller. So let's address that. So we go into our blueprint, section lengths. Let's make 10, for instance. Compile and save. Save and compile would be better order. So you can see that now it's thinner. You can do it 5 or whatever. So let's just receive it. So select everything. And in this case, just file export selected would not help. We need to merge them first, probably because they're blueprints. But anyways, it doesn't work. So we're merging it together into static mesh that I know where it is. That's why I'm just looking for it. So I'm overriding the mesh that I already have. Save. So this is my mesh with my tree. Right click, asset action, export, and I export it in the same folder, the same file where it was before. I'm saving it. And if I go here and I just pay attention to the gap, and if I go here and I reload geometry, you can see that the gaps became smaller. And again, you know, when we have thickness, it will be less noticeable too. So if we look at our tree right now, and it's moved only because we moved it in horizontal projection, if you remember. So now you can see that it's pretty much, these gaps are pretty much invisible. So depending on your situation, you might want to fix it, or you might not need to fix that. What you can also do is when you move in your points in here, you can also know that, okay, the first points will be gone. So might as well, you know, take it into account while moving the splines around. So yeah, at least, but at least this is a viable option too. And also, while now, when we have our initial spline, you can see that there are way more points than it was before, because now our the distance between them is smaller because we used twice smaller mesh to work with, and that's where our resample here can be useful. So now we can do 0.2 here, or if we don't do this, then we have the same amount of way more dense spline. It doesn't really make any difference here though. But why it changed? That's interesting. Aha, it changed because I'm not using this resample. 3. And what about transform? Maybe this will help a little bit. Maybe a bit smoother. I guess. So as you can see, there is like never really a solution that fits everything. In every particular case, you just probably will have to just go and look and see what's working and what's not. Maybe if I do it even bigger. Oh no, it doesn't help. I might as well go into tree trunk generator, and maybe this root is just needs to be addressed a little bit. Well, first it needs to be found though. No. Or maybe a little bit of everything will just help it. Maybe a little bit more smoothing. No, it's almost fixes it. 0.4 again. No. 0.3. Ah, hold on. I need to select this. So, well, in this case, it will not even be visible because it will be under the ground. So yeah, you can see the principle of how to deal with this. It's not like you can have a solution that fits every potential issue. I mean, that can fit every case. Or maybe you just need to add a bit more twisting, and it will fix it too. So in every case, you need to just look into what's going on. And I can also, as you can see, change the where it twists and where it's not. I guess now it's only twisting only in top. What if I mirror it? Oh yeah, yeah. Maybe it's twisting too much now. So in any case, it's a useful tool, and we end in this part of tutorial with this result, which is, as you can see, my tree from Unreal Engine. Let's look at it again in here, and let's unselect all the branches. So yeah, this is our branches, flowers. This is our trunk. And well, all the branches are this smooshed together. So this is almost the result that we came up with, and we'll continue the next time. Thank you for watching, and have a nice day and good luck.